Okay, this is lesson 51 for 8th grade, and today we're talking about negative exponents, and then we're going to relate that to our scientific notation, but we're going to talk about scientific notation for small numbers. Up to this point, we've only been dealing with positive exponents and scientific notation for very large numbers, so we'll see how those relate. So first, let's talk about negative exponents. Alright, it says, to recall from lesson 27 that we subtract the exponents when dividing exponential expressions that have the same base. So if we have the same base, x and x, we can subtract the powers. And they show us how to do that. That's only when we're dividing. When we multiplied, we added them, but when we divide, we subtract the exponents. So we can understand this law by applying what we know about exponents and division. Alright, so this really means x to the 5th divided by x to the 3rd, written this way, same thing, x to the 5th divided by x to the 3rd. This means x multiplied together 5 times, x times x times x times x times x. We've got 5 of those, and then we've got 3 on the bottom, all being multiplied. And we can cancel out some of these x's because we're multiplying on the top, multiplying on the bottom, so we can kind of take them out just like factors, basically. So cross out 1x, 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 and you get 1 over 1, 1 over 1, 1 over 1, and you're just left with 2 x's, so that's where that x to the second comes in. But the book takes that shortcut of just saying, okay, same base, we're dividing 5 minus 3 gives us 2. Alright? Now it says we want to consider the result when we reverse the numbers in the division. So, following the laws of exponents, the exponent of the quotient is negative. Because if we do x to the 3rd divided by x to the 5th now, we get 3 minus 5, which is x to the negative 2, because 3 minus 5 gives us a negative 2. Alright, so now let's apply what we know and try to understand the meaning of what x to the negative 2 would mean. Alright, that means we've got 3 x's on the top, 5 on the bottom, and these should be 1s. Looks like a cutout. But we can cancel those, and those, and you're left with 2 x's on the bottom. So 1 times 1 times 1 is 1. X times x times all the 1s is basically x times x, which is x to the second power. So what we're finding is x to the negative 2 actually equals 1 over x to the second. So we're finding that this equals 1 over x to the second. And we can actually, this brings up another exponential rule for us. No matter what this number is, we're always going to get the reciprocal or flip it, okay? So basically, x to the negative 2 is the reciprocal of x over 2, okay? So we're basically bringing this down and turning it positive. So yes, it's the reciprocal of x squared. And no matter what this number is, it's always going to be that way. It'll be the reciprocal of whatever x to the n is, alright? So we're flipping it, and that will be our, we'll find out later that if we have a negative exponent in the bottom, it will bring it up to the top, but I don't think we get into that today. We'll have to see. If we don't, that's coming up. But for now, just know that if you have a negative exponent, it's going to be the reciprocal, basically, of the x to the n, or whatever. So we'll just take a look at a couple of those to make that a little more clear. So if we just look at the powers of 10 here, we see this little pattern. And we have to note that 10 to the 0 is 1. Remember, anything to the 0 power is going to equal 1. Alright, so 10 to the second power is 10 times 10, or 100. 10 to the first is just 10. 10 to the 0 is 1, so far we've gone down. 10 to the negative 1, we bring, that is 10 to the negative 1 equals 1 over 10 to the first. 10 to the first is just 10. So we get 1 over 10 over 0.1. 10 to the negative 2 equals, we're going to bring this down, but turn that to positive, and that is 1 over 10 to the second, or 10 times 10 is 100, so 1/100th, or 0.01. So we see that we're getting smaller numbers as we go down the line with 10, when we change the exponent into a smaller number. Alright? Alright, so let's take a look at this real quick. Which of the following does not equal 10 to the negative 3? Alright, so 10 to the negative 3 should be 1 over, so we're going to flip it, 10 to the third. So this is 10 to the negative 3. Another way to write this is 10 to the third is 10 times 10 times 10, and that equals 1 over 1,000. So this one's good. 1 over 1,000 is okay. Another way to write this as a decimal is 1/1,000, or put 1 in the thousandth place. So this one's okay, but it is not negative 1,000. Okay, so it is not D. It is not equal 10 to the negative 3. So it's not negative 1,000. A, B, or C are all different ways we could write 10 to the negative third power. Okay. So we don't get a negative number when we have a negative power. Keep that in mind. Alright. Now what we're going to do is apply our exponent laws here. We are multiplying 10 to the negative second times 10 to the negative 4. We have the same base and we are multiplying. So that means this will equal 10 to the negative second plus, so it'll be negative 2 plus negative 4. And this, we think about this, we can't let our adding of integers go to waste. We have to remember those rules too. So a negative plus a negative gets us more negative, and we are at negative 6. So it'd be 10 to the negative 6. Think about being at negative 2 degrees and then going more negative. Okay? Now B. 10 to the negative 2 divided by 10 to the negative 4. Same base, so we know we're going to get another base 10. And this means 10 to the negative 2 minus negative 4. So when we divide, it says we can subtract our exponents. Okay? So we've got negative 2 minus a negative 4. And whenever we subtract an integer, we could rewrite it as 10 minus the negative 2 plus its opposite. So we actually have negative 2 plus 4, which is 2. So 10 to the second power. Alright. I guess one other way you could have looked at this one is we actually have, if we look at it that one way I was talking about before, a negative basically says we're going to flip it around. So it's like the reciprocal kind of, right? So if we flip these around, we can just swap places. This is a negative, this is a negative. We've got 10 to the 4th over 10 to the second. And now if we subtract, we get 4 minus 2, and that is 2. So 10 to the second, we can do it that way too, because once we flip them, we turn them positive, okay? Another way we could have done A. We would still get 10 to the negative 6. Let's think about what 10 to the negative 2 means. That's 1 over 10 to the second times 1 over 10 to the 4th. Now if we multiply 1 times 1 is 1. 10 to the second times 10 to the 4th. Did I do that one wrong? Negative 2 plus negative 4. Oh no, we're still okay. This is 10 to the 6th now. 2 plus 4 is 6, but we can represent this as equals 10 to the negative 6. So that one might not have been as easy to see, except for we know that if we have 10 in the top, it's going to be to a negative power since it's in the bottom right there. So whichever way you want to think about it, you can just use your integer laws when adding or subtracting with that to probably make it a little easier. But as always, we have a bunch of different ways to think about these. So, alright, let's simplify these real quick. 2 to the negative third power. Anything to a negative power is going to, so imagine we are going to bring it down. So it'll be 2 to the third, and it's over, or 1 over 2 to the third. And 2 to the third is 2 times 2 times 2, which is 8, so we get 1/8. B goes back to some of our old school roots here. We have a negative 2 to the third power. You might remember that if we have an odd exponent, we're going to get a negative answer. And then we just look at what is 2 to the third. 2 times 2 times 2 is 8. So this one does come out negative 8. If you don't see that, this actually means negative 2 times negative 2 times negative 2. And negative 2 times negative 2, 2 negatives multiplied gives us a positive, and then 4 times a negative 2 gives us negative 8. So that's another way we could have done it. So just to show you that a negative exponent doesn't mean you're going to get a negative number, but in this situation we do get a negative number. They're just showing you how they're different. Okay. If we simplify this, we have the same base. 3 and 3 are our base, so we could, and we are multiplying, we could add our exponents, and we would get 3 to the 2 plus negative 2, which is 0, and anything to the 0 is 1. Another way we could look at this, 3 to the second over 1, so I'm just putting this over 1, doesn't change it. And 3 to the negative 2 means we have 1 over 3 to the second. And if we multiply these, we've got, what, 9 over 1 times 1/9. And we'll end up getting 9 over 9, which is still 1. So we get a 1 there, either way we look at it. Okay, I'm going to check my time quickly. We're getting there. Try to hurry up here. Express this with positive exponents and simplify. Alright, so we're going to want to, first thing we're going to want to do is take this thing and rewrite it. X to the negative 1, y x squared, and y negative 2, and z. And we can put this all over 1. Okay. And what we can do is anything that's negative we can drop to the bottom and turn it positive. So this means 2, and x goes on the bottom here, x to the first on the bottom. And y x squared stays up here because that's already positive. Y to the negative 2 drops down and that becomes this. And then we have a z left over here. So basically anything to the negative power switches to the bottom and turns positive. And now we see how many more things we have on top than we do on the bottom. So this equals 2, and then we have one more y on top than we do here. So we've got one y that will cancel out with one of these y's. So there's no y left here, and we've got one left down here. We've got one x down here. This is gone, but it cancels out with one x up here. So we have an x z all over one y. Alright, I'll show you one other way you could have done this without doing it this fraction way. If we write this and reorder some things that it's all being multiplied, I'll put all my x's next to each other and my y's next to each other. -2 and Alright, and remember when we're multiplying and we have the same base, we can add the exponents. So negative 1 plus 2 gives us, I'll go up here. Negative 1 plus 2 gives you 1, so x to the first. This has a 1 here if you don't see anything. 1 plus negative 2 is negative 1, and then you've got a z. And then anything that has a negative exponent you send down and turn positive. So 2xz, and we bring this y down, and we still get the same answer. 2xz over y. Alright, I think I'm going to turn this into a part 2. So stay tuned, we just have a couple more left for part 2.